There is a place on the planet where life explodes in impossible colors, where every square meter of ocean pulsates with more species than entire forests. We're not talking about Australia's Great Barrier Reef, but rather an even more extraordinary marine territory, the Coral Triangle. Stretching 6 million square kilometers across the tropical waters of Indonesia, Malaysia, Papua New Guinea, the Philippines, the Solomon Islands, and East Timor, this region is home to 76% of all coral species known to science. Here, in the turquoise depths of the Western Pacific and the Celebes, Banda and Sulu Seas, lies the epicenter of Earth's marine biodiversity. 600 species of coral build underwater cities, 3,000 species of fish dance among the reefs, and countless life forms still unknown to humanity wait in the blue shadows. This is the primordial cradle of the oceans, where evolution has been working at an accelerated pace for millions of years. As the sun rises over the warm waters, which oscillate between 27 and 30 degrees Celsius, a silent spectacle begins. Corals that grow inch by inch over decades, fish that change sex to ensure the survival of their colonies, and bioluminescent creatures that transform the underwater night into living constellations. The Coral Triangle is not just a geographic region. It is a life-creating machine, a natural laboratory where nature tests its most daring experiments. Dive with us into the depths of this forgotten paradise, where every wave carries secrets from millions of years ago and every creature tells a story of adaptation, survival, and impossible beauty. The coral reefs of the Triangle are not just colorful pebbles on the seabed. They are metropolises built by billions of microscopic architects over millennia. Each coral polyp, no larger than the head of a pin, secretes calcium carbonate, creating its own external skeleton. Multiplied by the trillions, these tiny builders erect structures visible from space. In the reefs of Raja Ampat, off the west coast of Papua, coral formations grow in towers that rise 30 meters from the ocean floor, creating vertical canyons where sunlight filters in golden rays through the crystal-clear water. Here, the temperature remains stable between 28 and 29 degrees Celsius, allowing the corals to grow up to 2 centimeters per year, a frenetic pace for these ancient organisms. Ocean currents, traveling at speeds of up to 5 kilometers per hour, bring nutrients from the abyssal depths, fueling this explosion of life that rivals any terrestrial ecosystem. The diversity of coral forms in the Triangle defies imagination. Brain corals with their labyrinthine convolutions that can live for 500 years, table corals extending horizontal platforms 5 meters in diameter like hanging gardens, and delicate fire corals whose translucent tentacles conceal stinging cells capable of instantly paralyzing small fish. In the shallow waters of the Komodo Atolls, where depths rarely exceed 15 meters, Acropora corals form branching forests that stretch for kilometers, each branch sheltering entire families of damselfish that defend their territories with ferocity disproportionate to their 2-inch size. At night, when the full moon rises over the Banda Sea, one of the greatest reproductive spectacles on the planet occurs: the synchronized spawning of corals. Millions of polyps simultaneously release gametes in pink and white clouds that transform the ocean into an underwater blizzard, an event so crucial that it determines the future of entire ecosystems for the next 100 years. Scattered like emeralds on the velvet blue ocean, the atolls of the Coral Triangle represent the ultimate maturity of reefs. In the remote Togian Islands, central Sulawesi, Perfectly circular atolls embrace lagoons with waters so calm they reflect the sky like liquid mirrors. These coral rings, some over 10 kilometers in diameter, are actually the tombs of extinct volcanoes that slowly sank over millions of years while the coral continued to grow toward the surface. The central lagoon, with depths ranging from 20 to 50 meters, becomes a protected nursery where green turtles lay their eggs on white sand beaches formed from fragments of coral pulverized during 1,000 storms. On the outer edges of the atolls, where open ocean waves crash against coral reefs, the energy of the waters creates an environment of constant turbulence that only the most resilient species can inhabit. The architecture of these atolls creates unique underwater microclimates. On the outer wall, which drops vertically to depths of 300 meters, updrafts bring cold, nutrient-rich waters from the abyssal plains, creating a plankton explosion that attracts pelagic giants. Mantas with 6-meter wingspans glide elegantly, filtering thousands of liters of water per hour through their specialized gills. Within the protected lagoon, gardens of cabbage coral grow in formations resembling giant underwater roses, each sheltering families of gobies that live in symbiosis with blind pistol shrimp. These tiny crustaceans, measuring just 3 centimeters, excavate burrows in the sand, while the gobies, with their sharp eyes, stand guard at the entrance. At the slightest sign of danger, a flick of the fish's tail alerts the shrimp, and both disappear into the tunnel in a split second. This partnership, refined by 20 million years of evolution, exemplifies the complex web of interdependencies that sustains life in the coral triangle. Above the mirror-like surface, a parallel dimension of life thrives. The triangle's nourishing waters sustain not only underwater creatures, but also some of the planet's most impressive seabirds. In the Derawan Islands, off the coast of Kalimantan, colonies of masked boobies establish precarious nests on fossilized coral cliffs that rise 40 meters above the waves. These diving birds, with wingspans of 1.5 meters, patrol the skies in triangular formations, their sharp eyes capable of detecting schools of flying fish at distances of up to 2 kilometers. When they spot prey, they fold their wings and dive at 90-degree angles, hitting the water's surface at speeds approaching 90 kilometers per hour. Their specialized anatomy, air sacs under their facial skin and reinforced skulls, absorbs the brutal impact, allowing them to penetrate up to 10 meters deep before emerging with silver sardines caught in their serrated beaks. Magnificent frigate birds dominate the skies with their unmistakable silhouette, angular wings measuring up to 8 feet from tip to tip, and forked tails that function as aerodynamic rudders. During mating season, males inflate balloon-sized red throat sacs to a diameter of 40 centimeters, transforming into pulsating scarlet lanterns visible from miles away. These pirate birds rarely land on the water. Their feathers are not waterproofed, preferring to steal fish directly from the beaks of other seabirds in breathtaking aerial acrobatics. In the mangroves adjacent to the reefs, blue herons wade majestically in water as shallow as 50 centimeters, their stylized legs leaving temporary footprints in the mud between mangrove roots. With calculated slow-motion movements, these birds wait motionless for up to 20 minutes before unleashing lightning strikes that pierce unsuspecting archerfish. The coral triangle supports over 100 species of aquatic birds, each occupying a precise ecological niche in this natural cathedral of life. In the shallow waters of the reefs near Bunaken, a single cubic meter of ocean can contain representatives of 50 different fish species. Here, diversity reaches its planetary peak. Vibrant orange clownfish with symmetrical white stripes establish territories in poisonous anemones, immune to the toxins that would paralyze other invaders. These tiny warriors, rarely larger than 12 centimeters, defend their anemone homes with surprising aggression, biting divers who dare approach too closely. The symbiotic relationship is perfect. The fish receives protection between stinging tentacles, while its feces fertilize the anemone and its constant movements oxygenate the invertebrate's tissues. Nearby, mandarin fish glide like living jewels, electric blues, neon oranges, and fluorescent greens creating psychedelic patterns on bodies just 6 centimeters long. These tiny reef dwellers are so venomous that almost no predator dares attack them, allowing them to swim exposed during twilight hours when they emerge from their burrows for elaborate mating rituals. In the deepest zones, where sunlight begins to fade at 30 meters, giant Napoleon wrasses patrol their domains. These colossuses with distinctive frontal protuberances can reach 2 meters in length and weigh up to 200 kilograms. Reef elders that live up to 50 years. Their powerful jaws crush mollusk shells and poisonous starfish that other fish avoid, playing a crucial role in controlling invertebrate populations. In dramatic contrast, schools of golden anthias form living clouds of thousands, each fish measuring only 8 centimeters, but together creating collective organisms that flow over the corals like aerial rivers. All anthias are born female, but when the dominant male dies, the strongest female in the harem genetically transforms into a male over the course of 2 weeks, a reproductive strategy that ensures the group's continuity. This sexual plasticity, shared by dozens of species in the triangle, demonstrates how life finds creative solutions to the challenges of survival in these competitive waters. When the sun dips below the horizon and darkness embraces the reefs, a completely different cast takes the stage. On the vertical walls of the Wakatobi Atolls, mimic octopuses emerge from camouflaged burrows, their 2-foot-long bodies capable of instantaneous transformations. In seconds, an octopus can mimic the texture and color of coral, algae, or even venomous lionfish, changing not only its pigmentation, but also its skin texture and body shape. This mastery of illusion, controlled by millions of chromatophores, pigment cells that expand and contract under neural command, represents one of the most sophisticated forms of camouflage in the animal kingdom. While hunting, the octopus flows through the reefs like liquid mercury, its 8 arms simultaneously exploring crevices where crabs hide. Each sucker, equipped with chemoreceptors capable of tasting the environment, transforms the tentacles into exploratory tongues that sense and taste independently of the central brain. In the open waters beyond the reefs, reef squids form synchronized hunting squadrons. These 40-centimeter-long cephalopods communicate through light patterns that pulse across their bodies, a visual language so rapid it changes 20 times per second, conveying information about prey location and attack coordination. Armed with tentacles equipped with toothed suckers, the squids dart at schools of lanternfish like biological missiles, capturing victims with pinpoint precision. Further down, at the reef's edges, where depths reach 50 meters, spotted eagle rays glide in ghostly formations, their 3-meter wingspans casting lunar shadows on the sandy bottom. These nocturnal navigators detect buried prey through electroreceptors on their snouts, sensors capable of detecting the tiny electrical fields generated by the heartbeats of mollusks hidden a foot beneath the sand. With jets of water expelled from their mouths, they dig craters until they locate and suck clams with their crushing dental plates. During the monsoon season, when southwesterly winds push nutrient-rich waters from the depths of the Indian Ocean, the giants arrive. Whale sharks, the largest fish on the planet, converge on the waters of the Coral Triangle in numbers unparalleled in other oceans. Near Cendrawasih Bay in Papua, up to a dozen of these leviathans can be spotted simultaneously, their meter-wide mouths filtering tons of plankton as they swim at leisurely speeds of 3 miles per hour. Each whale shark sports a unique pattern of white spots on its bluish-gray skin, fingerprints that allow scientists to identify individuals and track their migrations across thousands of miles of ocean. Despite reaching 60 feet in length and weighing up to 20 tons, these giants are so docile that divers can swim inches from their massive bodies, observing parasites that live permanently in their 6-inch thick skin. Oceanic manta rays also frequent the cleaning stations scattered throughout the triangle reefs. With wingspans reaching 7 meters, these rays glide through the waters like alien motherships, their cephalic fins funneling plankton into generous mouths. On the Komodo seamounts, manta rays form orderly lines at specific locations where cleaner fish, small, 4-inch striped labrids, operate hygiene clinics around the clock. The manta rays hover motionless while dozens of cleaners remove parasites, dead skin, and infected tissue, a mutualistic arrangement that benefits both parties. Some manta rays visit the same cleaning stations for decades, faithfully returning to the reefs where they were cured. Scientists have documented individuals over 40 years old, proving that these giants can witness entire generations of reef life. When manta rays perform their spectacular leaps, jumping 10 feet above the surface before crashing into the water with deafening explosions, it's speculated that they're dislodging stubborn parasites or simply celebrating the joy of existence in these fertile waters. Beyond 30 meters of depth, where sunlight has lost its red frequencies and everything takes on shades of blue and green, forests of gorgonians colonize the vertical reef walls. These fan corals, some 2 meters tall, orient themselves perpendicular to prevailing currents to maximize plankton capture. Their protein skeletons, more flexible than the calcium carbonate of stony corals, allow them to sway gracefully in the 6-kilometer-per-hour currents without breaking. Among their branches, pygmy seahorses the size of human fingernails, just 2 centimeters, camouflage themselves perfectly, their body protrusions mimicking the polyps of their host gorgonian with microscopic precision. These miniature creatures spend their entire lives, up to 5 years, on a single gorgonian, mating and producing offspring without ever swimming more than 50 centimeters away. Males carry fertilized eggs in ventral pouches, making them the only seahorses that undergo true pregnancies, releasing fully formed young after 30 days of development. In the crevices and caves that pierce the reefs 40 meters deep, barrel sponges assume monumental proportions. Some of these filter-feeding organisms reach 2 meters in height and are over 300 years old, silent survivors that witnessed the arrival of the first European explorers to these waters. Each sponge filters up to 20,000 liters of water per day through microscopic canal systems, extracting bacteria and organic particles with an efficiency exceeding 95%. Their hollow interiors harbor entire ecosystems: translucent, 2-inch shrimp that never see direct sunlight, gobies that evolved without pigmentation, and even sea snakes that use the sponges as shelters during storms. The internal architecture of these sponges represents biological engineering optimized over 500 million years. Ventilation systems that would be the envy of modern architects, ensuring constant water flow even in stagnant depths where oxygen becomes scarce below 5 parts per million. At the top of the reef hierarchy, gray sharks patrol territories they defend with absolute ferocity. In the waters of Sipodon, an underwater mountain rising from the abyssal depths, resident groups of 20 to 30 sharks establish domains they maintain for generations. At 2 meters long, with muscular bodies designed for bursts of speed reaching 40 kilometers per hour, these predators keep herbivorous fish populations in check, ensuring that corals are not suffocated by opportunistic algae. Their prominent eye sockets grant exceptional binocular vision, allowing them to calculate distances with deadly precision during twilight hunts. Most fascinating is their ability to detect electromagnetic fields through the ampullae of Lorenzini, facial pores filled with conductive gel that sense the electrical emissions of beating hearts, even under 30 centimeters of sand. This sixth sense makes it impossible for prey to hide. The very act of living, the pulse of a frightened heart, becomes a beacon for predators equipped with biological technology more advanced than any human instrument. On the sandy flats between reefs, scalloped hammerhead sharks perform their nocturnal patrols in groups of up to 100 individuals. Their bizarre heads, lateral expansions that extend a meter in large adults, function like living antennae, distributing electroreceptors across a massively increased surface area. This adaptation allows them to scan the sandy bottom like biological metal detectors, locating hidden rays with surgical precision. During the day, these sharks form complex social aggregations on specific underwater mountains, where hierarchies are established through subtle body postures, pelvic fin angles, arching of backs, in a body language that scientists are only beginning to decipher. Dominant females occupy central positions where currents are strongest and oxygenation is optimal, while juveniles as small as 3 feet orbit the peripheries, learning social protocols that will determine their future reproductive success. This social system in sharks, discovered only in recent decades, reveals that these ancient predators have emotional lives and complex relationships previously attributed only to mammals. Despite its apparent robustness, the coral triangle faces unprecedented threats. Over the past 3 decades, coral bleaching events, caused when ocean temperatures exceed 31 degrees Celsius for prolonged periods, have devastated reefs that took millennia to form. Stressed corals expel the symbiotic zooxanthellae that live in their tissues, losing not only their vibrant colors, but also their main source of nutrition. If conditions don't normalize within 8 weeks, entire coral colonies die, turning underwater gardens into graveyards of white skeletons covered in opportunistic algae. Scientists documented declines of up to 50% in coral cover on some Indonesian reefs between 1992 and 2020, a rate of destruction that threatens to collapse ecosystems that have remained stable for 10 million years. Overfishing exacerbates the crisis. Removal of herbivorous fish allows algae blooms that smother recovering corals, creating vicious cycles that turn vibrant reefs into marine deserts dominated by toxic algae. Still, there is hope woven into the extraordinary resilience of these ecosystems. In the remote waters of Raja Ampat, where government protections limit fishing and tourism is carefully managed, reefs demonstrate a remarkable capacity for recovery. After bleaching events that killed 30% of corals in 2011, long-term monitoring revealed that recruitment of new polyps, coral larvae settling and establishing new colonies, restored cover to pre-bleaching levels in just 12 years. This resilience depends on networks of marine protected areas that function as seed banks, allowing currents to transport larvae from healthy reefs to degraded areas. Local communities in the Triangle archipelagos are implementing traditional management systems called SASI, centuries-old practices where reef areas are periodically closed to allow recovery. When these ancient wisdoms are combined with modern science, transplanting nursery-raised corals, restoring herbivore populations, and monitoring by artificial intelligence, the future of this cradle of marine life becomes less bleak, offering a template for ocean conservation on a planetary scale. When the full moon rises over the waters of the Coral Triangle, an extraordinary acoustic phenomenon unfolds beneath the waves. Contrary to the popular belief that oceans are silent kingdoms, nocturnal reefs resonate with complex symphonies, the snapping of pistol shrimps generating shock waves of up to 200 decibels, the vocalizations of croaker fish grunting through vibrating swim bladders, and the ultrasonic calls of spinner dolphins hunting along the edges of atolls. Researchers have discovered that healthy reefs produce richer and more diverse soundscapes than degraded reefs, a finding that allows us to assess ecological health simply by listening. Fish and invertebrate larvae, drifting into the open ocean after hatching, orient themselves toward healthy reefs by following these acoustic landscapes across hundreds of meters of open water, using hearing as a biological GPS that guides new life to suitable habitats. At depths beyond 60 meters, where sunlight no longer penetrates sufficiently for photosynthesis, bioluminescent creatures transform the darkness into underwater galaxies. Venus comb jellyfish pulse with waves of blue-green light that course through their 30-centimeter-long gelatinous bodies, creating mesmerizing kaleidoscopic effects. Firework squids, no larger than 8 centimeters, eject clouds of bioluminescent mucus when threatened. Curtains of light that confuse predators as they escape in the darkness. These displays are not mere abstract beauty, but chemical languages refined over 400 million years. Mating signals, territorial warnings, camouflage against light that allows creatures to be silhouetted when viewed from below against the illuminated surface. The Coral Triangle, even at its darkest depths, pulses with life that has evolved brilliant solutions, literally, to the challenges of survival in a world without sunlight. This is the legacy of an ecosystem that represents not only maximum biodiversity, but also maximum evolutionary creativity, a natural laboratory where life experiments with possibilities our imagination can barely grasp. If you've dived with us through the crystal-clear waters of the Coral Triangle and marveled at the exuberance of this secret cradle of marine life, please leave a like so we can continue bringing the hidden wonders of our planet directly to your screen. Subscribe to the channel and activate the notification bell so you don't miss any episode of this journey through Earth's most extraordinary ecosystems, places where nature still writes stories of resilience, adaptation, and indescribable beauty. Share this documentary with friends and family because knowledge is the first step toward conservation, and each viewing raises awareness of the urgency of protecting these underwater treasures before it's too late. Together, we can ensure that future generations will also have the privilege of witnessing the symphonies of colors, shapes, and life that make the Coral Triangle the beating heart of the world's oceans.